Great to see you. Super excited to have Hamel on the podcast today. Hamel is a longtime writer in the space of evals. He's an evals influencer. I followed a lot of his content before I even started Coval and have really admired what Hamel has put out into the world and how he thinks about the problem. I went to a talk he gave early as I was starting to think about my company, and that's actually where we met. And since then, I think Hamel has really followed along the Coval journey, and it's always great to hear and learn from Hamel.
Thanks for having me. I'm an independent developer in the space. I'd really enjoy talking about evals because I do consulting, and the primary bottleneck everyone faces is evals. I was answering the same questions over and over again in my consulting. And so I decided, hey, I should have some educational materials around evals as a way to scale that consulting or make it have an impact as opposed to one-on-one sort of customer engagements all the time, which is why I've been writing about evals. And I'm really excited about what you're working on at Coval for this reason. So thank you for having me.
And your course as well has been awesome. So I actually was in the last course, and Hamel has a course on evals of like deep diving on all sorts of topics over the course of 8 weeks, 12 weeks. How long is it?
Oh, it's 4 weeks actually.
Over the course of 4 weeks, you can learn everything about evals. Fast time to value. There's just so many interesting things that I've learned, even though I think you typically work with a broad range of generative AI evals. I think a lot of this applies to voice, especially how to think about evals. Something that you talk about a lot is how evals take up 60 to 80% of your time and should be really the core driver. People should be thinking about evals as part of the product development lifecycle, as the PRD, not as like Python unit tests or this kind of afterthought that only developers think about. And I think that's something that I've seen a lot of people get wrong. What does that mean in practice? What does that mean for the shift of how you should be thinking about evals on your team? What people get wrong?
We have this word evals, and I almost feel it's not really its own distinct thing. It's just part of the software development lifecycle for AI. It's not, oh, I need to go do evals or I need to budget for evals. It's really just how you should be developing to think about how you can measure your AI system. It doesn't mean you need to measure every single thing and get bogged down in complexity. It means thinking about high value things you should measure and measuring that. And evals, the reason that term exists really is as opposed to testing, because we've had testing in software for a really long time. So why have the word evals? These are stochastic systems. They're non-deterministic, so they're very different than software. And so how do you test a stochastic system? A lot of people don't have intuition about that. It turns out that in machine learning, we've been doing that for a really long time. And so you can bring a lot of that knowledge over to AI product development. You don't need to learn everything about machine learning necessarily, but those tools already exist. Evals is if we plucked those refined tools from machine learning that help us measure systems and evaluate them. That's what we call evals, and that's what we're doing. You worked at Waymo on computer vision systems and machine learning and doing evals. So I'm like curious, like what your affinity towards evals, like how that developed.
Yeah, definitely. I think that's what we hear. I think a lot of developers actually feel a little bit guilty around not doing evals, or they're like, oh yeah, we should be doing evals, but we're not, which I don't think is the point. I don't think everyone should be doing evals, or every single thing you're doing should be test-driven development out of principle. But I do think it requires this organizational shift from thinking about things as for X, I expect Y. Or when I ask my agent about can I get a refund, it should always respond with this message. And if I do it once, it works, right? That obviously isn't the case. Shifting the paradigm of how you think about that process now that things are non-deterministic, that is what requires the kind of product development lifecycle shift. It requires an organizational shift because the goals around, especially around voice, I think how to improve an autonomous voice system, it's like we want to handle 100% of call volume is typically the goal, right? So you actually have really clearly defined goals and what you want to be doing, but how to get there and what to prioritize is often really hard to navigate. And I think this is actually really similar to Waymo and self-driving. It's really clear what you want to do. You want to be able to drive safely on the road all the time from point A to point B anywhere in the city. That's really clear. Even a little kid on the street knows what a self-driving car should do. But how to get there, where engineers should spend time, which teams should spend time on what does it mean to make progress in that specific area can be really hard to do. At Waymo, there's lots of teams that were consumers of simulation, onboard teams, developing the onboard models for driving the car, product managers who are thinking about where do we invest, what is the product roadmap. You have operations, you have different teams in strategy and operations and deployment, all looking at these simulations. Agents are now not necessarily just an engineering problem, but this is actually an operations problem. This is a company strategy and positioning problem. This is a sales problem. This is a product problem of where do we invest our engineering resources. It mirrors what probability of success for this specific type of use case or this specific query or this type of conversation, what probability of success is acceptable, and how do we make progress on that is a completely different way of running an engineering team. So yeah, I think to equate it to like we should write unit tests diminishes just how much thought is acceptable. I think if you said you spent 60% of your time writing unit tests, that seems pretty scary as an engineer. But I actually think spending 60% of your time writing, thinking about how to evaluate and improve as a core part of your product is a great use of time.
Yeah. I think one part that's often overlooked with evals is data analysis. And people usually don't include the activity of data analysis inside the regime of evals, but it is the most critical part, maybe the most important part of evals is to quote, look at data. And, this looking at data, it sounds very trivial. It almost trivializes it. Maybe we should stop saying looking at data. That's why I say analyze data. If you're building something, you want to look for patterns and make sense of user interactions that your customers are having with your AI application. You want to navigate that and tease out what's happening so that you can build a better product. And before you even get to evals, you need to be able to reason about, hey, what should you be working on? What should you prioritize? Where are things breaking? All of these things, they fundamentally boil down into having good data skills and data tools. And that knowledge that you get from data analysis should inform evals. Because again, you don't want to eval everything. You want to eval targeted set of things that you know that will have an ROI. How do you know it will give you an ROI? Because you have done data analysis up front that shows you where things are going wrong. When you do data analysis up front, you end up discovering lots of things that don't even need an eval necessarily. You might discover different bugs that are trivial that you can just fix. You might discover other kind of things that, there's always lots of opportunities to discover by systematically analyzing your traces.
I think looking at your data, there's so many things that seem simple at a high level, but then they're actually really hard to capture in practicality. I'll give an example even on our side, like workflow analysis, being able to say, did it follow these steps in this order? Feels pretty easy to do at a high level, but then to actually make that work again and again over time and be a metric that you can trust at scale is really hard to do. And that's on our side. And on the customer side, it's pretty easy to say, I want to do an appointment intake. I want to ask what time they're available. If they say they want to book the appointment, then I'm going to call a tool call that says book the appointment. Cool. Seems easy. But then there's all these cases of what happens if they interrupt while you're booking the appointment. Does it actually book the appointment? Does it not? How do you confirm with that person? Are you seeing people are saying the date in a way you weren't expecting? There's all of these cases that come up once you start looking at the data. What if there's lots of background noise? What if there's a TV in the background? If there are two people talking? If they take a long time to look at their calendar? All these timing aspects. I think that is where the complexity comes in, is those real world cases. And I think we saw this at Waymo as well. It's very easy to do things in theory, but to actually do this in practice is a lot more complicated because the world is messy. So how does looking at your data change for conversational analysis, and what's really similar between a lot of the processes that you've already worked in, like conversational AI, where it's not just Q&A, but actually multi-step conversations is relatively new in the past 6 months.
Yeah. So I would generalize conversational to say multi-step agentic workflows in general. The things where you have lots of turns. Those turns can include lots of things: retrieval, tool calls, back and forth with the user. So you're talking about more complicated traces that are not trivial, just one single shot turn. And there's some tricks you can use when you're doing error analysis. Error analysis is a very specific technique inside this data analysis that you might do of your traces that help you understand what's wrong quickly. It involves looking at traces in a structured way, but some tricks there are, number one, what we teach people is what you want when you're reading your trace, you want to stop at the first most upstream area and then move on. You can get stuck over analyzing a trace. You can try to figure out like, oh, what are all the different things that are happening? Let me nitpick it, spend a lot of cycles. We've done this so many times that we know the most upstream error you have oftentimes is the most important error because these things cascade. There's a causal chain of events. And that's why we say, look at the first upstream error. Most applications are multi-step, multi-turn agentic applications. I rarely come across trivial single shot things. I just don't see that. When I think about evals, that's all I think about, this multi-turn. The second piece of it is error analysis. And error analysis helps you get an idea of the patterns of failures in your application. And it helps you like prioritize which ones you should work on. Then comes like evals. You might end up writing some evals for those, which are test cases. For a test case, you need to reproduce that error so you can iterate against it and see if you're making progress. With conversational stuff, it can be a little bit challenging. So there's some naive approaches. One naive approach is n-1 approach. Take the trace up until the error, use the n-1 turns and feed that into a system. That's very limited. It can work. Before you use the n-1 approach or any approach, try to reproduce the error in the most minimal way possible. Can you reproduce the error in fewer turns? Can you reduce the complexity? Just like software development, if you hit a bug, what you want to do is like minimally reproduce the error. Same situation here, that really helps. And then after that, create a test case that can reproduce it. This n-1 approach is okay. It's not perfect because your system might be dynamic and changing.
And have state.
Yeah. And you have to be really creative sometimes when you use the n-1 approach to make sure you're triggering the error and accounting for all these other variables. And then there's simulation. The simulation is a non-trivial problem, but I think I'll give that over to you. You can tell us more about the simulation bit.
Yeah. I think so many of the principles for conversational evaluation are the same. It's your data, take the errors that you're seeing in production, reproduce them, iterate on them, and then make sure that they're not regressing, set up CI/CD pipelines, set up regression tests that like maybe run more asynchronously, and then monitor for new things in production. Like how can you monitor for unknown unknowns? Where I think it differs is the actual implementation of it. In order to reproduce a lot of conversational problems, you have to use simulation because it requires a buildup of state. It requires like all of these different different environments, for example, having background noise or that timing. So reproducing it just with text might not capture all the transcription problems or the chance of transcription errors. But even if you can do it just with text, there is that state buildup over time. And then also your agent might not even get to that point anymore because you've changed the way your agent works. These tests can become very brittle very fast if you just use those. I think there's a time and place for them. It's nice because they're a lot more focused and determined. They're a lot more focused, so they're more likely to produce. We have two types of simulation that help create a spectrum from hard-coded conversation to a fully non-deterministic simulation. You can start with, okay, I want a refund. And then that is so general, it could go in whatever direction based on how your agent is responding. We can also do things like follow this rough structure of like first ask for a refund, then complain again, and then finally give up. Or then finally say, thank you so much for your help. Or you can actually re-simulate from a transcript. So this is similar to what I think you mentioned, which is somewhere along the lines of re-simulating from logs, taking a real example, but you're still re-simulating that to see if you even get to that state. You can dynamically respond to the agent implementation up until that point. That test is going to be more realistic, but still not as brittle as having a hard-coded conversation. There is definitely still a place for having that hard-coded conversation, especially when you're trying to really compare apples to apples, reliably produce that error for a tool call or something else like this. So I think that's kind of the range that we see. And it's not one size fits all. I think evals is much more of a broader umbrella term for lots of different tools in your toolkit. There's observability and pre-production testing, simulation, hard-coded tests, unit tests, Python. Just good old Python with a function call does a great job for tool call evaluation, as well as being able to do more, maybe you're just setting up mocks, all sorts of tools. And even within that, you might have happy path versus adversarial testing versus trying to jailbreak an agent, compliance tests, etc. So I think evals is just such a broad umbrella term. I actually think of it much closer to the term infrastructure than to a specific activity. It could be data analysis, review of recent runs, labeling tasks, or running simulations. So there's so many activities within the term evals.
Yeah, I like that. I like that framing that there's a spectrum. What we also tell our students is to get better test coverage, you can often perturb your traces, which is like the middle point of that spectrum all the way to simulation. Is there any time where simulation becomes too expensive? For example, I was working with a company and they're building a security agent for code, and the environment they have to spin up is very complex, like a Docker container installed with a bunch of stuff in it. And the thing that we kept going back and forth on is the simulation itself is very expensive. You have to create this entire world, essentially.
Yeah.
Similarly with a database, if you're building a data science AI, and you want it to work across many different domains and companies, you might want to build synthetic data warehouses, which
Yeah.
sounds scary because you need to build all these worlds. So what do you see people doing with this out there?
I think one thing is that a lot of this becomes easier with simulation because you can take shortcuts. So you have less data, less scale, etc. We don't really work as much in that area of the agentic infrastructure, like agentic infrastructure around, etc. But I would say on the voice side, you also have similar of like how do you like also build a voice agent? You're building, making sure it has low latency, follows instructions, etc. And I think generally the problem is a lot easier because you can cheat. You can just give it simple instructions of what you're supposed to do. You don't have to operate in a large knowledge base or lots of ambiguity or handle all these different scenarios at once. You can just have one prompt for one test. So that makes it easier, but there's definitely still those challenges. And if you're not calling lots of complicated tool calls, latency becomes easier. So there's a lot of things that make the simulation problem easier than the real problem. That being said, it's definitely still, to the question of expensive, it's definitely still much more expensive than writing like LM eval tests, or certainly more expensive than like Python unit tests. And so I think that's where simulation evaluation strategy is really interesting because you're constantly balancing speed, latency, and signal. How can you get as much signal for the lowest cost as fast as possible? But of course, you're always trading off those things. In the limit, you could run millions of simulations and theoretically get lots of signal, but that would incur a very high cost. Self-driving robotics, this is a very common problem that you run into is like, how do you only test for the things that you're currently working on, the things that are currently hard, creating this concept of hill climbing sets. So you're not trying to just cover every test case that you've ever run into. You're trying to capture the things that are just a little bit easier than what you're working on, just a little bit harder. You don't want to be running tests that you just know you're going to fail every time. Waste of compute. You just know you're bad at those things. And then you also don't want to be running tests of like 100 times of set a timer or answer the phone and book a regular appointment because you just know that works. And I think you've written about this as well, is just you really want to be focusing on that margin of error. So the things that you just started fixing and now are working, you want to make sure you're not regressing on those. You want to have some core workflows, and then you also want to have the things that you're just becoming better at. And this is especially true for voice just because they're more expensive. You might be running 25 to 100 simulations versus 100,000 simulations.
One thing I'm curious about is, I don't know if you recall this project. It was some time ago. It feels like a long time ago, but it was like LLM as a kernel. Someone made it where it was like an entire computer in a way that was an LLM. You give it the code, it'll execute your code. You can insert a database row, but there's no database and there's no kernel. It's just an LLM pretending to do everything. This project like glued together all of it. It didn't work 100%, but it was cool. It was very funny, right? It's like,
Yeah.
it worked. It really worked. And it had a UI. You would like navigate to another page, and it would like on real time. There was no like HTML or any kind of thing. The LLM would just render it on the fly each time. Do you remember this?
No, I don't, but it sounds super cool. I'm going to go look
Okay.
at
It's
it.
really interesting, and it makes me wonder, in the limit, can you simulate these systems as well? Maybe.
Yeah.
It sounds like maybe not right now, but it seemed interesting, right? Like how, and if you could do that with just an LLM as a kernel, you might be able to shortcut some complicated simulation environments that are very expensive.
Yeah. I think this is interesting because as voice and chat become more multimodal, like you have buttons in chat or you're talking on the phone and it sends you a text message and then says I'll follow up with an email later, these types of cross-platform, but still all conversational. That's definitely an interesting case of how do you start to render buttons and pictures to represent those different chat inputs? I think one of the reasons why voice is a really exciting, truly autonomous agentic use case is because it's so constrained. You have two people talking to each other, going back and forth, mostly one turn each, and it's over voice. So there's lots of possible signal in that, but you're still relatively constrained in what you can do. It makes it really exciting for being able to autonomously handle situations end to end because there is a lot more infrastructure already in place due to automating this space. People have already thought very hard about what does it mean to be successful in this situation. There's all sorts of customer service operation teams that have put into writing, like, this is what it means to be successful. This is the standard operating procedure. These are the steps you should take in order to resolve this situation. And I think that's a lot of what you talk about is like, how do you get really clear on what you're supposed to be doing? Like, what does good look like? I think is something that we see a lot as customers come to us and they say, tell me if my voice agent is good. And you're like, what's your voice agent supposed to do? And they say, you can talk to it about anything. Where are you spending your engineering time? Is that something that you see as well?
But yeah, I see that all the time. When I see a product with a little text box that says, ask me anything, I know that things are not going to be good. So first of all, we're not communicating reasonable expectations to the user. What do you mean, ask me anything? You should never have that expectation set. I encounter that quite a bit where people basically want to copy and paste ChatGPT into their product and say, we could ask ChatGPT anything. You should be able to ask us anything and we can do anything. The people that haven't bridged that gap between, okay, yeah, it's not like you just copy and paste it. You want to be able to do certain tasks in your application, want to be able to make sure those are like really good. I think it's really important from a product perspective to understand what your users want to do, what the highest value use cases are, and try to scope it properly so that you can develop and test against something. It would be like telling an engineer, hey, build an app. And the engineer is like, to do what? And you just said, I could just do anything. We don't know what to build. No one can be successful in that regime. So it would be the same thing with AI. You don't want to do that.
And even if you look at your data too, you're like, oh, someone came to my app to buy groceries, and then another person came here to journal, another person came here to keep a spreadsheet. You're now going to build in 10 different directions. I think this is something that especially with voice, can be deceiving because the medium looks the same, the interaction model looks the same. And so features in voice it's hard to put your mind around, like, what is a feature in voice? But a feature is like a specific type of workflow. So it's what are you putting in that text box and what are you trying to achieve on the other side? Same goes for like when you're having a conversation, like what are you trying to achieve out of that conversation? And how can you think about that as a feature that you're saying, okay, what's supported, what's not supported? I think that exercise, a lot of times people are like, we don't want to spend that long on evals. But I think you're actually that's a product. You're spending that time on product. You're thinking about what does my product actually do? What is it supposed to do? What is it not supposed to do? What do I want to make really good in sacrifice of other things that now it's not going to be as good at?
Yeah, absolutely. So it really comes down to product thinking. For example, if your AI assistant is supposed to help you schedule meetings and, there's a calendar that has available times. If you're not dialed into that problem and trying to make that experience really good, you might be lazy and just say, let the AI respond with bullet points of times. No one wants to see that. If you're going to do a scheduling app, okay, fine. Be able to talk to the AI. This is what I'm trying to do. Have the AI, have your application render a widget that says,
Yeah.
okay, here's why don't you click on one of these? Like, this is like what we have for you. And then you just do it. You don't have to go back and forth on text about what times are available. That's just brittle, right? And so that only happens, that clarity and that design only emerges if you focus on specific tasks and make the user experience really good on that task.
Totally. Or I think we see this a lot with voice as well, is that voice, it can be really difficult to get the voice agents to say dates out loud correctly. It will get like the day wrong, or it will say the date in a weird way. And there's all these different error modes. And so being able to, for example, have a tool call that gets the right date versus having to try and generate that, like what dates are available is tomorrow versus what day is yesterday. Being able to have structured ways of saying those dates out loud so that you're not just throwing a huge lump of text at the LLM, but you actually are solving specifically for that problem. If you focus on the problem and really try to nail that scheduling flow, you're going to get a lot better results than if you just use OpenAI real time out of the box and slap it onto your product.
This concept called criteria drift has been studied extensively. What happens is when people look at data and they look at outputs of an LLM, they significantly revise like what they want. It's like you have a set of requirements in your mind. It turns out we are really bad at fleshing those out in one shot. By reacting to what the LLM is doing, you refine what you want. When you see what the LLM is capable of and understand some of the brittleness of it, you say, actually, it would be good if it did XYZ instead. It's really important to do that. If you don't, criteria drift is a good thing because it's moving you into the zone of refining what your product should be. It's not just about looking at data so you find what's broken. It's actually a product, like a core product activity.
Yeah. And being okay with what works and doesn't so that you can push people more in that direction. If you see a lot of your users trying to use your application for something it's not intended to do, a valid response to that is we don't support Japanese in our application versus trying to do it poorly. Or we don't support looking up the weather. If you ask about the weather, it just doesn't respond at all versus saying we're going to try and respond to every question you ask us. I'm curious how you think about, like, something you talk about a lot too is cascading failures and how upstream failures then can cascade down into downstream failures. This is obviously super important with voice AI because you have so many models working in concert together. So you have text to speech to text, VAD, they're all happening all in one turn. And then you have lots of turns that are all chained together. How do you think about getting really high reliability in the context of having so many potential points of failure that then can multiply?
Yeah. So I think it starts with making sure you're doing the right data analysis of these systems that have lots of handoffs. And there's some analytical tools that you can use to help tame the chaos. So conceptually, what this looks like, what this flow looks like is this like complex graph with like lots of loops and things. But you don't want to just visualize that because you would just, again, drown in complexity. So one way that you can analyze this is create a transition matrix between the transition matrix is open-ended. Like the entities in the matrix can be whatever you want, but like to start with, it can be like different agents, different steps of your workflow. And then you have at each transition from one step to the other, you can quantify failures. And it's up to you how you want to quantify those failures, but you can start with counting failures and seeing where the hotspots are in the transition matrix. And you can even try to order the transition matrix so that certain quadrants of the matrix will be upstream because those are the first steps. If you see hotspots there, you really want to pay attention. But it gives you like a view that a human can understand because we're only good at looking at 2 dimensions.
Totally.
Humans can't really look at 3 dimensions, especially with data, we get overwhelmed. But that's a good analytical tool that tends to make sense. It takes practice massaging stuff in there. Like every system is a little bit idiosyncratic, like what is an error and what you propagate into that transition matrix, failure matrix. You have to be thoughtful that you're like having enough signal and not too much noise, but it's effective. Once you see that, you can go about things the normal way of having targeted evals for hotspots, then iterate against those. And that's how you resolve all of these issues.
Yeah, I love that idea. I think that's something that we should incorporate into our product. This analysis of where in the workflow are you failing? At what point along the way? How early in the conversation are you failing? Are you failing right away? Are you failing at the very last step, etc.? If someone wants to get started, so if they're listening to this and they're like, this is awesome. I've never heard of evals before, and I want to implement voice AI evals. How do you convince your team that evals are a good investment and framing that value to the team?
You shouldn't try to sell your team on evals at all because you're going to hit a lot of resistance. The best way to talk about evals is to actually do it and not say the word evals. Start with doing some data analysis. In every meeting, say, okay, these are the issues we found. We fixed issues 1, 3, and 5. We have some tests. And you just keep doing that. And that is really effective. People over time are like, what are you doing? How are you always finding these things so fast, systematically? You're always on top of what is going on. And how is that possible? And then you can start telling them about evals. You can start telling them about
spreading
and so
the eval.
yeah. I mean, it's basically just leading with the outcome. So not the idea, not anything, because it really does have lots of value. You just have to show the value, and that's what I would recommend.
Totally, which is a great engineering principle in general. I think sometimes engineers forget the reason of being is you're trying to build something that people want and help solve a problem. It doesn't matter how beautiful your code is or how perfect your system is if it doesn't help anyone do anything.
What programming language you're using.
No one cares if you wrote it in
Yeah,
Rust if you built
yeah,
another to-do list.
yeah.
So yeah, I think that principle of really like how does your engineering efforts produce impact certainly applies to evals as well. If your system works perfectly, you don't need evals. You can just keep letting your system work perfectly.
If your system works perfectly, it's a little bit suspect. Maybe you should think about if it's that trivial, is that defensible?
Yeah, 100%. This has been awesome. I know I learned a lot, even after spending all day, every day in evals. As always, it was great to chat. Thanks so much, Hamel, for coming on the podcast.
Thank you for having me.